Here's homework help for number 83 in 6.3. The crane shown in the figure are lifting an object that weighs 20,240 pounds. Find the tension in pounds in the cable of each crane. So we have our cranes lifting an object, and so we can think of this middle point right here as our origin. And so we have several angles here. We have 44.5 degrees. We have 24.3 degrees here from the horizontal. And then I would say we have one more going straight down because that is the weight of the object. And so just thinking about how many degrees that is, I will say, theta 3 is 270 degrees, right? It's being pulled straight down. And I would say we know that magnitude. I'm going to give that as the magnitude of W, the weight of the object. That is going to be 20,240 pounds. So we will write 3 equations, one for each crane and one for the weight of the object. So we have the left crane here. And so this left crane, the angle from the horizontal is 24.3 degrees, but really we're going to look at the angle from standard position. And so we see that is just under 180 degrees. So I'm going to call this U, crane U on the left. And so the left crane, that angle is 155.7 degrees. Again, you take 180 minus 24.3, you get 155.7 degrees. So I'm going to write the equation. So U is the magnitude of U, which we don't know what that is. We're trying to figure that out, times cosine of the angle of 155.7 degrees, and then I, plus sine of 155.7 degrees J. So we can do the right crane. We'll call that B, the right. So right crane, and that angle we can take it as it is, which is 44.5 degrees. So theta is 44.5 degrees. So V is the magnitude of V, cosine 44.5 degrees I, plus sine 44.5 degrees J. Last, let's just do the object, and it's pulling straight down, right? So everything is holding in place. And so let's look at our object. We know that I'll call that W, as I called it before. So W equals the magnitude of W, cosine of 270 degrees I, plus the magnitude of W, sine of 270 degrees J. Now we actually know what our magnitude is. That is W is 20,000. Magnitude W is 20,240 degrees. And cosine of 270, we actually know what that is. The x value is 0. And then we have the sine, which is 20,240. And sine of 270 degrees is -1. So we're going to write a system of equations. We're going to write a horizontal. So that's going to include all of our cosines or our i's. And then we'll write a vertical equation. And so that is going to include all our sines or the j. So horizontal, let's do the horizontal first. So that's going to include all of our cosines. So our horizontal is going to be the magnitude of U, cosine of 155.7 degrees. And I'll just leave the i's off for now. And then plus the magnitude of V times cosine of 44.5 degrees plus the magnitude of W, and this is just 0, right? The cosine ended up being 0, and that's all going to equal 0. Okay, so it's all holding everything in place. So that's our horizontal equation. Let us do our vertical equation. And so we're just going to take all of the signs. So we have the magnitude of u sine of 155.7 degrees plus the magnitude of v sine of 44.5 degrees plus our last one. We know that that's just going to be negative 20,240, and that all equals 0. So what we can do is we can isolate our variables on the one side and then move the 20,240 on the side, on the right side, by adding it. So, but these are our two equations that we have that we're going to use, and we're going to solve using a system of equations to solve for the magnitude of u and the magnitude of v. So let me rewrite the equations. Magnitude of u, cosine 155.7 degrees, magnitude of v, cosine of 44.5 degrees, equals 0. Then my other equation is magnitude of u, sine 155.7 degrees, is magnitude of v, sine of 44.5 degrees. And then what I'm going to do is I'm going to add the 20,240 to both sides. So now this equation equals 20,240. So let's go ahead and plug everything in the calculator. We're going to round to 2 decimal places for now. So if you plug it in your calculator, cosine of 155.7 degrees is 0.91. And then if we plug in cosine of 44.5, that would be 0.71 equals 0. And then we do the same for the bottom equation. So sine of 155.7 is 0.41. And then sine of 44.5 degrees is 0.70, and that equals 20,240. Oh, I apologize. This first value is a negative. Sorry. So cosine of 155.7 degrees is negative 0.91. That makes sense. Cosine of 155 is in quadrant 2, and therefore it should be negative. All right. So we're going to solve the system. I'm going to solve for v. So I'm going to multiply the top by 0.41, multiply the bottom by 0.91 in order to cancel out my u's, since they already have opposite signs. So using the calculator, we'd have negative absolute value of u times 0.3731 plus magnitude of v times 0.2911 equals 0. Then the second line would be magnitude of u times 0.3731 plus magnitude of v times 0.637 equals 18,418.4. Then we'll add them together. So then we'll have the magnitude of v is 0.9281 equals 18,418.4. Then we'll want to divide by 0.9281 to both sides to be able to solve for the magnitude of v. So the magnitude of v ends up being 19,845 pounds, and that is the right crane. Then in order to solve for the left crane, then we're just going to have to plug in v into one of our equations. And so I'll go ahead and plug it into our original equation up here. So this is the magnitude of u, 0.41, plus the magnitude of v, which we know is 90,845 pounds, times 0.70 equals 20,240. So then if you plug that all in your calculator, you would get the magnitude of u would be about 15,484 pounds, and that is our left crane. So I hope this helps. Thanks for watching.